In this lesson, we're going to look at triangular forces and the relationship with vectors. So what is a force? Well, you can think of a force as something that acts on an object, either to push or pull the object, or perhaps to change its direction. In this image of our dog riding a bicycle, we can see that there are a few forces involved. Firstly, we have gravity pulling the bike towards the ground. We also have air resistance as the bike moves forward. We also have the forces of the dogs pressing down on the bicycle. And there are also upward forces as well. Some of these forces are invisible or indirect forces, and some of these forces are direct forces. So for instance, when the dogs push or pull the handlebars, that would be a direct force. So to build the relationship between vectors and forces, we're going to do a little activity. So in this activity, I'm going to sketch the vector A equals 3i plus 2j, B equals minus I minus j, and C equals minus 2i minus j. Feel free to do this as well. Now, by now we know enough about vectors to know that the vector A will finish at the point 3, 2, and it will start at the origin because it's a position vector. B will start at the origin as well and finish at the point minus 1, minus 1. And C will start at the origin and go to the point minus 2, minus 1. After you've drawn in the three vectors, we're going to add these three vectors and sketch a graph of the sum of these vectors. So by this, I mean that I'm going to take vector A, then I'm going to add on vector B to the end of vector A, and then I'm going to add on vector C to the end of vector B. So start with A plus on B. Make sure the start of B is at the end of A. And then once I've drawn vector B attached to vector A, I'm then going to draw vector C. What we notice here, it's not a coincidence that the sum of these three vectors will be 0. That means that when we add these vectors together, their starting point is their finishing point. And in fact, we make a triangle here. When we add these three vectors together, I get 3i plus 2j plus minus I minus j plus minus 2i minus j. Collecting the I terms, notice for the I component, I get 3 minus 2 minus 1, which is 0. For the j component, I'll get 2 minus 1 minus 1, which is also 0. So the result here is indeed the 0 vector. There is no change in the starting position to the finishing position when we add these vectors together. So how do we apply this to forces? Notice in a triangular force question, you'll be given three forces that are acting on an object, usually pulling it in three different directions, such as in the picture above. Now, if the object is still or it's moving at a constant velocity because of the forces, then these vectors will have a sum of 0. What we can do is we can rearrange these vectors into a triangle of forces. And that way we can find the angle between the vectors originally and the strength of each vector. If the angle between, in our original diagram, between force A and B, or vector A and B is alpha 1, the angle between vector B and C is beta 1. The angle between vector C and A is going to be called gamma 1. In my triangle, I'm going to find the supplementary angles to these. So the angle between A and B in my triangle, I'm going to call this alpha 2 because it corresponds with the angle between A and B in the original. In that way, alpha 1 plus alpha 2 will be 180 degrees. If I label my angle between vector B and C in my triangle beta 2 to correspond with beta 1 in the original, they will add to 180 degrees. And also, if I label the angle in my triangle between vector A and C, gamma 2, Gamma 2 plus gamma 1 in the original will also equal 180 degrees. So your job in these questions is to go from the original diagram, create the triangle, find missing angles and magnitudes of the forces, and then relate it back to the original. Just to finish up, I'm just going to leave you with a few key points before you go on to the second video and the examples. So the process of creating a triangle of forces is used to help us find the angle between forces acting on our object, or the strength of these forces, sometimes called the magnitude. Things to remember: we can only use this method when a particle is at rest or moving at a constant velocity. This is the only time the sum of the vector forces is equal to 0. In these questions, using cosine and sine rules can be helpful once you form the triangle. Forces tend to be measured in newtons, or we write it as kgWt. The force of gravity is always equal to the weight of the object itself, and obviously gravity is directly downwards. Note here that the magnitude of a force is not the length of its vector in centimeters or units. A magnitude of a force or its vector refers to its strength only. Okay, I'm going to leave you here, and then the second video will be about the example.